Hi everyone, thanks for coming here today to listen to this talk about how we can go about measuring novelty and diversity. Measurement is an essential part of the process of monitoring and evaluation. Why is this relevant? Firstly, novelty is relevant to innovation, and innovation is seen as central to the process of economic development. If innovation can be defined as invention plus use, then invention, particularly as seen by patent offices, requires novelty. Novelty is necessary but not sufficient. Secondly, diversity is relevant to equity or fairness. The lack of diversity in access to resources, goods or services suggests a lack of equity. A focus on diversity is especially relevant in the current political context as seen in the United States, where the whole set of ideas relating to diversity, equity and inclusion is facing determined and powerful opposition. Somewhat independently, technological developments supporting the operations of online social networks and online businesses have required the use of recommendation algorithms. These can have a huge influence on the kind of information and products we are exposed to given our current preferences. Their design parameters can give different weights to popularity, diversity and novelty. Finally, when viewed in a wider evolutionary context, diversity is recognized as the key to long-term survival in the face of unpredictable futures. How are these concepts related? Novelty and diversity are different things, and they are measured differently, but they are also related concepts. Novelty is a measure that describes individuals, whether they be people or entities or events of some kinds. But diversity is a property of an aggregation of entities. The assessment of novelty necessarily involves some form of comparison with multiple other entities. I'll give a practical example of this shortly. How can we define novelty? There have been many different attempts to define novelty in one measurable form or another. A recent paper by Bavato reviewed and summarized this work and concluded that there were two underlying dimensions behind many of these definitions. In their words, novelty is generally regarded as a function of frequency or proximity, or in other words, rarity and dissimilarity. But in their paper, there was also another important difference in the way novelty can be assessed, which is the place of time in these definitions. There are two options. We can look at things within a historical perspective, or only in terms of what currently exists. In this paper, I have focused on novelty as being about dissimilarity as seen by comparisons within the present. There are also multiple views on how diversity can be measured. The most useful of these is a three-dimensional definition, as described by Andy Sterling in his 1998 paper on the economics and analysis of diversity. This builds on definitions and measures of diversity used in a range of disciplines, especially ecology. The first is variety, which is the number of kinds of things. The second is balance, which is the relative number of each of these kinds of things. And the third is disparity, which is about the degree of similarity between these kinds of things. I will be focusing largely on disparity, but there is also a useful fourth facet of diversity, which I recently came across, which takes a more macro perspective. This is called beta diversity, which is the extent to which the composition of two or more groups, such as habitats, have an overlapping membership of different types, e.g. of species. I will touch on that briefly. In this slide, I outline a relatively simple procedure that can be used to measure novelty and diversity. Firstly, we can ask for each entity we are interested in what other entity that entity is most similar to. So if I ask this question to myself, I might ask what other evaluation method is most similar to the most significant change question, and I might answer outcome mapping. If the same question is posed to proponents of a range of other evaluation methods, these judgments about the relationship between pairs of entities can then be aggregated into a simple network structure represented in the form of an adjacency matrix, as can be seen in the next slide. We can then measure two aspects of the network structure using a measure known as closeness centrality. Closeness centrality is calculated as the average shortest path link from a node in a network to all other nodes in the same network. Closeness centrality can be measured using widely available software packages such as UCNet. In this application, we will use the inverse of this measure, which is about distance rather than closeness. And it will be the total of the shortest distances rather than the average of these. We can use that measure in two ways. Firstly, we can find the entity within a network which has the greatest distance between it and all others as a measure of novelty. Secondly, we can calculate the average total distance between each entity and all other entities in the network as a measure of diversity. Here is a simple toy example of an adjacency matrix representing the aggregated results of the similarity questions. The cell value in row 4 and column 5 indicates that the entity in row 4 is most similar to the entity in column 5. You might notice that in this proposed procedure, the nature of that similarity has not been predefined, other than by using a broad suffix to the similarity question, such as most similar evaluation method. But there is no reason why this similarity question cannot be followed by a more open-ended question which asks something like, in what way is this entity most similar to this other entity? Using network analysis software such as UCNet, the matrix data which you have just seen can be converted into a network visualization, as seen here. I have annotated this diagram with some distance measures generated from the matrix data. In this example, we can see that node 6, representing an entity of some kind, has the highest total distance from all the others, 34 in total. The unit of measurement used here is what is called a geodesic, which is the individual link connecting one node to another. It is the number of these that matter rather than their physical length, as seen in this diagram. You can also see that the nodes 7 and 9 have the shortest total distance to all the others, and that the average shortest distance between one node and all the others is around 25 versus 34 for the most extreme case, node 6. Groucho Marx had a friend who once said to him, "Life is difficult," to which Marx responded, "Compared to what?" By now you are probably asking the same question. Just how significant is that value of 34 for node 6? In this slide you can see two comparators that might be useful. The first is the maximum possible average shortest distance. This will be found in a linear structure like the one seen on the right. Using the same number of nodes, the maximum possible average shortest distance here is 33. On the left you will see a very different star-like structure. Using the same number of nodes, this structure minimizes the possible average shortest distance down to 1.9. So for any measure of novelty or diversity, we can compare it as a multiple or a fraction of either of these two measures. I have found a real-life example of the structure on the right. It described participant choice behavior in a parivo.org exploration of alternative futures for the UK after Brexit. It captured some of the very diverging views amongst people at that point in time. I now want to touch upon some related but different kinds of approaches to the measurement of novelty and diversity. What you see on the right here is a diagrammatic version of a theory of change. Straight away you can see a variety of different causal pathways between the events at the bottom and those at the top of the diagram. But each of those pathways is made up of component events. So we're not simply comparing one entity to another, but one set of entities to another, that is, two pathways. This brings us back to the idea of beta diversity, which I mentioned earlier. If we want to quantitatively capture the diversity of these pathways, we need to look at the overlap in the membership of components within different pathways, both at the average amount of overlap and the most minimal degree of overlap, representing diversity and novelty, respectively. If you eyeball a diagram alone, you can probably see that the most novel, i.e. least similar pathway, is probably the one on the far left. This is the one single pathway from the blue node at the bottom to the mauve node at the top. However, eyeballing the rest of the structure is not very helpful at all because it is so complex. In this slide you can see another alternative approach. The procedure which I described in the first half of this presentation can be described as an agglomerative approach, taking individual entities, finding those which they are most similar to, then aggregating these into a network structure is an aggregative approach. The alternative approach is a divisive one, where the key question is not about similarity, but difference. This is represented by the graphic on the right. Here we start off at the top of the structure with a set of 9 entities which are all in one big group. We are then asked to split these into 2 groups of any size, representing what we think is the most significant difference between them. That question is then reiterated until all those entities have their own unique category, or share a category where there is no significant difference. Looking at the structure as a whole, we can use the same geodesic distance-based measures to calculate diversity and novelty within this structure. But we can also calculate variety and balance-based measures, as also shown in the graphic. I now want to bring the presentation to an end with a more practically orientated set of questions about methods of measuring novelty and diversity of the kind that I've just described. I've listed here 4 possible types of applications using some broad categories. In the time that remains for a discussion, I would really appreciate if you could share your thoughts on how the methods that I've described could be used in any of these areas, and of course any difficulties that you think might also be involved. Thank you. By the way, a video version of this presentation is available on my YouTube channel at the address that you can see here.